if it is one particular set of functionality you can assume. So for example, if you are doing this student database project, then I can think of functionalities as basic operations, which include insert, delete, the sorting in different ways, the interface that we provide, and perhaps there are some special operations that we want to do. And so I can think of these as 4 different models. In practice, every module itself can contain multiple files internally. Right now, we are not bothered about that. So for the simplicity, we are considering that every module contains only one file, one .c file. Okay. So this module, which is basic ops db, which contains basic operations, has this one file, basic ops db.c, which is essentially having all the function definitions of the functions which basic ops requires. And there could be a set of functions, lot of functions, out of which those functions which other people are going to use, their declarations are written in basic ops db.h. Okay, over here. So there could be some functions which are internal to basic ops db.c, which it doesn't want to expose to outside world. It is perfectly possible. So, but the functions which it wants to expose to the outside world, they are written in this .h file. And I mentioned that as a good practice, the first thing that basic ops db.c guy is going to do, or the programmer is going to do, is going to include the basic ops db.h file itself in its own file. And that is not absolutely required, because you are anyway going to write the definitions inside this file. And if there is an ordering issue, you can always take care of that. But this is require more from perspective of consistency, that if any change that you make in basic ops db.c in the function declarations, it should get reflected in basic ops db.h and other way around. So many times the someone else will agree on your behalf to make changes into basic ops db.h, so that someone else's code can go through, but those changes are not reflected back in basic ops db.c, and you will find out much later. So this can be avoided if you include this basic ops db.h. This file itself will not compile, so the writer of this file would know that there is something wrong, and immediately the action can be taken. So this is one typically, although this is not followed by everyone, but is one typical good practice that we can always have. For example, if I don't include basic ops db.h, is perfectly okay. Fine. So so this is about the basic ops, basically this particular model. Okay. Similarly, every module will expose its own .h files, right? I can have similar .h file for interface.c also. And over here, I will say it is interface.h. Okay, and similarly, lot of other these files. Like the sortdb.c will have its own .c file, which I can write over here and call it as sortdb.h. Fine. There could be, in addition to this, there could be one .h file which is kind of generic, in the sense that everyone requires, which could be global declarations. Okay, but global declarations of what? Let's say that it might be something like globals.h, I can say. Okay, now there may not be any corresponding .c file attached to that. There could be just, so these contain all the global declarations of typically, let's say, structure. So I can say global.h. Okay, so it contains the structure declarations, let's say, okay, or hash defines and lot of other things. The global.c file does not exist, let's say. So in that case, it may not have any function declarations, which is perfectly fine. It's more about the variables and not only variables, but we will see the issue with the variables basically. But before that, it is, let's say, more about structure declarations or enum declarations. So these all user types that we are defining, all those things can be written over there, or hash defines, and all these things can be written in globals.h. Can we write some integer, some, let's say, I require a global integer, which is int, let's say, what do I call? Let's say that frequency. Okay, it may be clock frequency or something like that. And let's say this variable is a global variable which is required by everyone. Shall we write over here? Okay, we have to wait. I mean, there are issues with this, so we have to wait for this. We'll not perhaps like to do it immediately. Okay, so let's remove it for the time being. Okay, so what typically they would, so and then perhaps everyone will include this include this hash include globals.h also. For example, over here, it will say hash include globals.h. So everyone might be including this globals.h because everyone requires these global declarations. Okay, fine. Now what? So now again go back. What are we doing over here? When this interface.c included basic ops db.h, basic ops db.h. Okay, db I missed out. Basic ops. What does it get? Now you have to go back to our first original class, the C programming hash include stdio.h class that we took. What did we discuss there? So what is happening when I include hash include basic ops db.h? Do the functions get linked? Do the function definitions come in over here that we were believing beforehand, or does library get linked because of that? No. So what happens over here? Any quick answer? When I say hash include basic ops db.h, what exactly happens? That was my first question. When I said hash include stdio.h, what exactly happens? So let me see basically whether you remember all that. Copies the .h file over here. In a way, you can say that it inserts the contents of .h file over here. Okay. So what is the idea? The idea is that this interface.c file might be referring to the functions which are, or other is might be calling the functions which are actually inside this basic ops db.c. And the compiler, remember one thing, that compiler compiles every file separately. So it compiles interface.c separately, sort.db.c separately, etc. So when it is compiling interface.c, it doesn't actually require the function definition of the functions that it is using from basic ops db.c. It requires other only the declarations. When do you require the definition? When does the compiler require the definition? The actual definition of the functions? It doesn't require in the normal compilation, in the first stage of the compilation, where it is compiling a single file to create the object file or obj file out of that. Yes, it requires during linking later on. After all objs are created, all of these objs essentially are linked together along with main.o, and then at that time it resolves all these cross references. Okay, in the sense that it knows exactly where the function exists and things like that, because at binary level it wants to call. So when it is compiling interface.c file, it doesn't require the function definition. It just requires function declarations, and that's what we are providing basically through this basic ops db.h. Okay, so it calls the function. As long as it calls according to the declaration which are made over here, compiler does not creep. It peacefully creates the obj file out of it. Okay, so as far as functions are concerned, our job is done. To say little bit differently, uh, it is like saying that actually any function from any file can be called by any function in any other file. Okay, so that way, in C language and many other languages also, at least the procedural languages which are like Pascal, and functions are considered to be globals, in the sense that they can be called by anyone from anywhere. Okay, only thing that they require, only thing that the calling file requires is the declaration. So as long as you provide the declaration, there is no problem. You can always call that function from anywhere, except for there is one particular restriction which I will mention later. In one particular case, it does not happen, which we make sure that it does not happen. But otherwise, by default, to say it, by default, all functions are globals. Okay. So, which is not the case with variables, by the way. So by default, typically the variables are not globals. So of course, they are not globals when they are defined inside the functions anyhow. But when they are defined outside of all the functions, you can say that it is global. But then there are some way in which you have to make those variables available outside. In case of functions, things are easier in the sense that you just provide the declarations and you get done basically. So this is what we are doing over here. And now you can imagine that different modules, okay, can cross-reference functions from other modules. And that which functions who is going to use from where, this is all part of the design. So there are two stages of the design. One is called as high level design, where the manager and the designer sit together and they decide that which module should be there and which module should do what. And then there is some what is called as low level design, where the actual programmers sit together and they say, for this particular model to be implemented, I require these functions from this particular module, and it needs to have these parameters, and then they agree upon that, and that agreement is termed as the output of that agreement is this .h file. So all .h files are published and said that this is the agreement that we have reached, and and this is what everyone requires. So the module writer or the programmer actually has to think ahead and figure out that if I am going to implement this basic ops, let's say interface.c, what all things I'm going to require from other modules basically, and in what format I require. So they have to also fix what is called as the first thing rather they have to do is they have to fix the data structure. Okay, so first they have to realize that whether they are going to use array of structures or linked list of structures or tree of structures or whatever, and after they decide all that basically, and then after that they say that now I require these functions from you. So everything starts from the data structure anyhow basically, although it is not being said, it starts from there, and then you decide that okay, now this is what we have decided, and now these are the functions I require from this module. This module has to implement these things, and the things proceed from that point onwards. Okay, so I believe this part is clear. Okay, any doubt up to this point? Because now I'm going to talk about the variables. Okay, so as far as the structure declarations are concerned, there is absolutely no problem. I mean, in this global.h, if I declare a structure, and then that global.h is included by everyone, all those declarations are available. So declarations could be basically they could be made available. So declaration that contents of .h file comes over here, it is like declaring that structure over there. So as long as it gets the declarations, perfectly fine. The issue comes in definition. Basically, definition meaning definition of variables, where the variables get allocated. I will discuss about that. But before that, anything else? No doubt. I'll just give few seconds extra. Okay. So I think this part is understood. Okay. Now let's talk about the integer, and let's say that there is one integer which needs to be global. So first thing it needs to be understood is that okay, where that integer needs to be declared and where it needs to be defined. Okay, these are two different things. Okay, so declared meaning you are saying that let's say that there is int frequency. Okay. So let me not write in globals.h for the time being. Let's say that is basic ops db.c. It declares a global variable called as int frequency. And let's imagine that this interface.c requires this frequency variable. Now there is a catch 22 situation. I hope you understand what is catch 22. It is like you do this, you have problem, you do that, you have problem. So interface.c requires int frequency. So it says, okay, basic ops db.c has already declared int frequency. And so I don't have to declare it. It's global. It is outside of all the functions. So I will not declare it. And I will like to access it basically in one of the functions by saying that I'm in this interface, it is setting this frequency to something. Let's say frequency equal to 10, which is let's say 10 time minutes. Okay, whatever it is, basically. I'm just taking some variable I require. So don't get into the meanings of this. Essentially, some variable I require over here, and this variable it is like global, so everyone wants to access it. Or it's just that it is being defined over here. In frequency is said over here. Now what happens? This when you compile this file interface.c, it is going to crypt. It is going to say that it doesn't know what frequency is. Okay, essentially it doesn't know that frequency is an integer. Okay, because it no one told it, right? And I mean you are now you can now understand this much better because I told you that interface.c file is compiled separately. When compiler is compiling interface.c, it doesn't know anything about basic ops db.c. It needs to be told. That's why all these .h files have been included over here. So it says that, so this compiler says, I don't know int frequency, that it is global or whatever. So I don't know what this frequency is. So you do one thing. Okay, you say, oh, you don't know. Let me tell you what int frequency is. Okay, let's say this int clock was there. So let's talk in frequency only. So let's say that it says, let me tell you that frequency is an integer. Okay, so it does this. Okay, the programmer does this over here, and it is expected that this is basically this frequency and this frequency are the same, but they are not. Now what happens is this interface.c compilation, in compilation might go through because it gets frequency, and then whatever frequency is referred to, it is uses that. So it uses it as a separate variable. Okay, separate. A location is allocated where this frequency variable is allocated. When you compile basic ops db.c over here, and it also has this int frequency, So it also goes through and its object file gets created, and there is a variable called as frequency get created. Now, because the compilation happened separately for these dots and these dots, there is no issue. In the second phase of the compilation, when you try to do the linking together, the linker realizes that there are two frequency variables. So which one is being refined? Both are global. So it creates a hassle over there. It says there are two variables with the same name frequency. I don't allow that. So your linking does not go through. I mean, you will see that, and the comparison itself is not going through because phase two of compiler, that is linking, is also part of the compiler operations typically when we compile. But then essentially it's the second phase of comparison, which is linking, which is not going through, and it says that the variable frequency is being declared, is being defined twice. It says, okay, it's defined multiple times. Remember, it uses the word defined. So it says because there are two memory locations with the same name, which is not allowed in the same program. So you have a problem, catch 22. You don't write it. Compiler creeps saying that I don't know frequency. You write it, and it says it is being declared twice. So what is the way out of this? So the way out of this is provided by this, the next qualifier, which is called as extern. So what you need to do is, in general, all the variables need to be defined. Okay, meaning this in frequency kind of thing should come only at one single place in all of the program, including all of the .c and .h files, not at multiple places. Okay, so only one, and it should not be part of globals.h file, because this .h file gets included at different locations. Okay, and then what happens is that if I include globals.h over here, and let's say this in frequency is in globals.h like this, then what is going to happen is, and moment globals.h get included in interface.c as well as in special ops.c, that this in frequency line comes here, interface.h as well as special ops. So it is as if that you are declaring it twice. So that's why perhaps this could be avoided, although something else can be done over here. But for the time being, for easy understanding, let's keep it in basic ops db.c only, because it is a property of, it is the property in the sense that is the ownership lies with basic ops db.c. So all definitions are inside .c file. So in frequency over. But now this guy has a problem, right? I mean, you do anything, you have a problem. You declare this, you have a problem. You don't declare this, you have a problem. So question is, what is exactly required by interface.c? Interface.c does not need to know where the frequency is, or where the, what is the memory address of frequency. It just needs to know that frequency is an integer, which is like a declaration, like a function declaration, right? I mean, when I give function declaration, I just say that this is, this is the prototype of the function. Say don't bother about where it is defined. So that is what it is required, and that is handled through what is called as extern. So what I can do is I can say extern in frequency, which means that to interface.c we are saying that this frequency is a integer variable, and is extern, meaning you don't have to allocate any memory for this frequency. Someone else will be doing that. Okay, so then this someone else over here is this basic observability.c. So one guy is the owner of this frequency. Okay, and the other guy is basically will just use it as extern int frequency. Okay, now things will go through that. What will happen as far as compilation of interface.c is concerned, it understands that frequency is integer, so it will just let it go through. And when linking happens, it will essentially find out where exactly the memory location of frequency is, and it will resolve those addresses, and so everything works fine. One thing which happens in such cases, no one has this int frequency. Everyone says it's extern int frequency. That should also not happen, because if everyone says that it is extern int, the individual compilation of every file will go through, but the linking will fail, because linking does not get the exact memory location. So it will say that frequency is not defined. Now you will be surprised. But what you have done is you have declared this through extern int frequency, but you are not defined. It is like saying that you have just provided the prototypes of functions everywhere, but you never defined the function. Okay, so it is exactly in similar way. So if I take that analogy, in general, I can say that the functions are all always externs. Okay, by default they are externs, or by default they are globals. Okay, so the variables need to be defined at one place, and they are essentially extern ints at all other places. Okay, so whoever uses requires it, he needs to do that. So which also means that this guy needs to also declare, basic ops implementer guy also needs to declare that which global variables he or she is defining. Okay, so that is also another agreement they have to make, that which global variables might be available. Okay, who is defining that? Remember that globals.h cannot do that. So maybe another way people do is that they say, okay, forget it. Rather, if I don't want, I really want a global, which is not property of basic ops db.c, etc. Another way is basically what I can do is I have this globals.h in which I will declare this as extern int frequency. Okay, and then I will keep this globals.c where there is no function definition in the globals.c. They're just declarations basically. It's just a nice way of doing things. That's why I'm describing. Otherwise, the earlier one which I said is also perfectly fine. But another way some people might prefer is that they will say, okay, I have what is called as, okay, I have globals.c. There is definition basically, now not declaration. So it says I have globals.c. So no function is defined and only variables are defined. So I may have int frequency over here. So only one guy takes care of the global definitions of variables. And then everywhere, everyone includes globals.h. So automatically it gets the external declaration also within them. So now if I do this, then perhaps I don't require to declare this as external frequency. Through globals.h, it will come. And now no one is owner of, there could be some variables where no one is owner of them. Then in that case, they could be pure globals. So this can be done for cleanliness purpose. But otherwise, most of the times, the other thing that I did, that in frequency is part of basic of db.c, and then that also can happen because sometimes you may want to refer to variables of other guy. So these are two different ways in which these things can be done. Okay, so this explains to you this extern. So what did we say in extern? That the variables need to be defined only at one single place, so that only one memory location is allocated for that name. But the declarations need to be available everywhere, everywhere meaning whoever wants to use that global variable, and that is done through extern in frequency. Okay, through this extern. That's why extern is a qualifier. I mean, when you say extern in frequency, it is like just declaring that frequency is integer, nothing more than that. You are not going to allocate any memory for that. Okay, and this could appear at as many places that you want. Doesn't matter. Okay, this is like function declaration. It can appear anywhere and everywhere. Doesn't matter basically. So this explains extern. So any doubt on the extern? Okay. So if any doubt on extern, I will take it in next 2 minutes. No doubt? Great. Now, if you understand this, now let me have exactly opposite requirement. Okay. And the opposite requirement is, now imagine that this basic ops db.h has a variable called as status, which is its internal variable. It's a global variable, but what basic ops db.c wants is that it is the status variable for execution of different functions it wants to use. Okay, for its own functions. Okay, but this is not a variable that basic ops db.c wants to share with outside world. Okay, which means that now, and basic ops db.c guy does not tell the other guys that he or she has a variable called as status. Okay, he says I have required this variable, I took this variable with name status. What do you want to, why do you want to bother about it? Now other guys also say, okay, we don't bother about it, it's okay. But now by chance it so happens that interface.c also, this guy requires name called this variable, and because status is the most obvious name, this interface.c also picks up the name which is called as status. Okay, now these are actually what these guys are saying, but why are they defining as globals in their file? Because they say this variable is required across different functions in their file. Okay, that's why they are saying that I am writing this name outside of all the functions. Well, this guy says I'm writing outside of all the functions. Now what happens is, but it's not global. So when this guy wants to refer to status variable, it is its own status variable. It is not the status of basic ops db.h that it basic ops db.c it wants to refer to. And this guy wants to refer to status, its own status. Okay, these two status are different, which was different case in case of frequency. Everyone wanted to use the same variable called as frequency. Okay, that's why only one single variable called as frequency. Now I want as many statuses as possible, and I don't want to put. So one thing I can do is, oh, okay, then you can. So now the problem is if multiple status variables are there. In compilation, there is no issue, but in case of linking, it will creep saying that there are multiple definitions of the same variable. So this is not allowed. Okay. Now, what is the way? I cannot say it is external int status because when a moment I say that, then only this status variable I will be referring. I don't want that cross connection. So maybe the manager comes and say, okay, why don't you do this, guys? I mean, you have a status, then you have this basic ops db.c file, right? Your name is, so you just use the name of your file. You say status bod, and this guy, it is still that you use status if, which stands for interface. So maybe this is how it gets resolved, but this becomes cumbersome. I mean, the programmers say this is too bad. I mean, every variable, if I had to attach with module, which by the way many times it has to be done, but they say, is there a way out? Basically, I don't want to do this. Okay, this is too clumsy. I mean, there are some other variables ijk I might be using. Are you going to tell me that I underscore bod and j underscore bod I should write? I mean, this is too much. So then for that there is another qualifier which comes into picture, which is called as static. So what you can do is that this variable status, basically int status, this basic ops db.c file declares it as static int status. Similarly, this interface guy also declares it as static int status. Remember, this declaration is still outside of all the functions. Okay, but some people who know about the static qualifier, they know it when the variable is inside the function. So this is a completely different thing I'm talking about. I'm saying that the variable is a global variable outside of all the functions, and I'm declaring that as static. So now what happens? So two things happen. Number one, that because this variable is being declared outside of all the functions in that particular file, let's say interface.c file, it remains as a global variable as far as this particular file is concerned. So any function can access this status variable defined in interface. Any function inside interface.c can access this status variable, which is defined inside of interface.c. This is definition, by the way. Okay. So this is static int status. When I do, it actually creates a variable called as status, but it says that this is a special variable which is only part of interface.c. And any function inside interface.c can refer to this status variable. Similarly, when basic ops db.c guy declares this, it says, okay, status is a global variable as far as this basic ops db.c file is concerned, but it is kind of local to the file which is basic ops db.c. It cannot be referred by outside. It can be referred by all the functions inside this basic ops db.c, but no one from outside. Okay, so it is restricting the access of this status. It is global only as far as the file is concerned, not for the whole program, which may contains all the files. So it is local for it is global for all the functions inside the file, but it is local as far as the program is concerned. Okay, so it is like saying that the static int status provides me a facility that I don't have to do b underscore bod over there, but essentially the same effect is achieved, and I don't have to do underscore if over here, but exactly same effect is being achieved. So essentially, this status now, this status here, and this status over here, they are two different statuses. They are not the same statuses, and it allows that. Okay, so which means that this is exactly opposite of extern. So in extern, what you did in extern, you had one single variable which you wanted to refer to everywhere else, and that's why this is possible by defining it once and then by declaring it at multiple times. Now the different people are defining this variable at different places. They are globals. They are their own globals, and we are not restricting that. We are not saying that you cannot use the global variables with the same name, but we are saying that we are restricting the access only for that particular file. Okay, and now things will still go through, and I mean it will not creep in the linking, because linker understands that this is only for this file and is only for this file. You may say how it does that. So imagine that it exactly does the way I described. That maybe it puts something a special. Don't pick me up on that. I'm giving the general idea. Okay, so the exactly how it will happen might be a little bit different. So general idea, you can think that in some way it puts some kind of identifier which identifies this variable only with respect to this particular thing. Now, does it make change and as underscore bod or etc.? I don't know. I mean, but that is the effect that will be achieved. Okay, as far as program is concerned, he or she is oblivious, because the compiler takes care of all that. As far as program is concerned, they just see variable status over here. Okay. So now these things will also work out. Okay. So any question on this? Now this external ID class told you what it is, and static I told you what it is. Remember, both external static I told you about for the global variables. Okay, for the variables which are global to the either to the file or to the program. Okay, and how to access them. Now any question? Because now I am going to go to the next level. Again, I will give you a few seconds to decide. No question? Good. So let's move ahead from this point as well. Okay. Now, yeah. Now, what you might require is maybe sometimes I told you that by default the functions are globals, and they can be used anywhere else basically also. Okay, that is the by default. But you may want to restrict functions also in some cases, and make it local to the file, but not outside of the file it needs to be used, because there could be some functions which are your own property and you don't want to expose those functions outside. And there could be these functions with basically simple names which might be shared across different files. For example, one name I can think of is I don't know whether I will have a space over here, but let me create the space. So okay, it does not allow me, so maybe I had to do the page layout. Okay, so now it will allow. So let's say that I want a function which returns back integer 0 or 1, or I might have returned back boolean also. We know enum now. Let me just have int, and I will say check status. Okay, and then there is some parameter list over here. Now it could be possible that there is, and this is a function which is defined, which is not to be given to outside world. This is its own function, and this guy happens to declare this function. Now what happens is even this guy interface.c also wants a similar function for itself. Okay, but he also does not want to give it to the outside world. So this guy also would, what he will do is he will also have a function which is basically it says int check status. And again, why the same name gets used? Because they don't talk to each other for everything, right? I mean, they are not supposed to talk to each other about everything. So he or she uses different parameter list, let's say over here. Okay, and uses internally. Now the problem is that they didn't expose it in .h. So the problem didn't happen. Maybe the parameter list may not be same. It might be different, but they didn't expose it to the outside world. So they will say, we didn't expose it. So, but they didn't talk to each other. Not everyone is going to say, oh, I'm using this name and you are using that name. I mean, they work separately. Many times they are geographically separate also. One team is working in Bangalore, other team is working in Tokyo, the third team might be working in Seattle. So all those things can happen. So they are not going to speak to each other with hundreds of programs. Now, in that case, when the whole program is still one, and when it basically gets compiled together, the linker is going to crypt saying that this function check status has different definitions and declarations. So I don't want it. Now I say, what is it? I require this function. I took it. Now again, manager comes and says, okay, you do underscore if and underscore bot. So of course I don't like it. So the C language says that, okay, why don't you do this? That if you wanted a function which is your own function, which you know that it's your own property, and you know that it is not a global function, in the sense that other models should not access it, you declare that function as static. Okay. So what is essentially static doing is it is restricting the access of this function. So within this file, anyone can call this function called as check status. But if in this file basic of someone is calling, it is the check status of its own that it is calling. And in this case, it is calling it is check status of this interface.c it is calling. So so what we are doing is we are restricting this function, so no one else can call these functions. Only the functions inside this file can only call this one. Similar to the variable, the global variable I told, right? I mean, the variable is global in the sense that any function can can use this variable inside this file, but one from outside use. Similarly, this function name or this particular function. I mean, this is not only declaration, there could be definition also. Okay. So there could be definition also over here. So only the functions inside this file will refer to this function, and functions from other file refer to their own function, which is check status one. So again, there are multiple copies of check status, but every module has its own copy. I mean, a different copy basically. So in this way, I'm making the function which was by default global, I'm making it static, or which was by default external, I'm making it static, in the sense that it is restricted to a particular file. And this use of static, perhaps typically it is not, it doesn't get taught in any C programming course, because as I told you, this has nothing to do with C programming per se. This is about, I mean it is there. If I want to explain static and external, I need to do that, but otherwise, then that's why people don't explain, because so many things have to be explained, which people think that this is not part of C language. But then this is part of the practice, that when you actually become programmers in industry, basically this is all you have to take care of. And these are the typical issues which come immediately. And when moment you start basically doing, even today you do in multiple files, you will typically take care that the same names don't repeat and stuff like that. But when you are not a programmer of all the files, then such issues definitely will crop up. And this is how the C language helps you out. Okay, so I told you about the extern, and I told you about the static also, the way it gets used. There is another way in which static gets used, which I will describe later, now rather. But what I described this extern and static, I assume that most of you perhaps were not aware. So because that requires a lot of other overview and perspective of how the whole program gets compiled and things like that. Okay, and how the project gets divided into different modules and all those things. So now we have done with almost all the qualifier, except for one use of another static, which many of you might know, that I have to just take it. But otherwise, the most important parts are done. So any doubt? Again, I will give you a couple of minutes before I proceed forward. Any doubt at this point in time? Okay, no doubt is coming in. So either everyone is understanding perfectly fine, is what I will like to assume. Okay, fine. Now let's move to the next use of static. So this is a use of static, which, as I said, that people will know if they look into Kernighan and Rich in a little bit more detail, and then one understands how the programming, how the implementation gets done in real life. The next use of static is the most one. I mean, somehow I don't know why. I mean, everyone talks about this static declaration, and somehow it is famous with almost all the students. The moment you ask the question, "What is static variable?" the people just jump in. Basically, they say, "Oh, this is the static variable," not the earlier one which I told. This one, basically, which I am taking. So almost everyone seems to know about it. Somehow it is. It looks little bit very very popular. So what this is all about is that, let's say that I have function func. Let's say, I have function func, and let's say that I have a variable which is, let's say, int num times, and let's say that, so let's imagine, or let's not num times, perhaps is not a good variable. Maybe I will like to take some status val. Okay, or let's say count of something, basically. Okay, and here the function ends, and typically what I do is I initialize, let's say, count equal to 0, and then I do some operations with the count. Okay, and I perhaps do count plus plus, let's say, over here, and some operations over here, and likewise. Now what happens in this case is that every time the function func is called, this variable count gets created fresh on the stack. We understand that, and then it gets initialized to 0, and then the variable count is incremented. And then if I do a printf over here, printf for count, I will get %d, and I will get, let's say, count. I will always get one, value of one. Okay, at this point. Now the requirement is little bit different. So what I want is I want a variable which is property of this function. Or rather, I want a variable which keeps a value across different calls of the function. So I want a count where initially when the first time it gets called, the value 0 gets set, and then it gets incremented, let's say, to +1. But next time when the same function is called, I don't want the value to be initialized again to 0. I want the value, the earlier value of 1 to persist. And now when I do count plus plus, I want value of 2 coming over here. And the next call I make, I want value of 3 coming over here. So one way you can solve this problem by making this count as a global variable. Okay. But it has to be attached to this function func. Okay, because some other functions may also have similar requirements and they might have their own count variable. So then every variable has to be attached, appended with the function name, just like we had to do that other variable I talked about, underscore module name or something. Similar things have to be done. So this I would say that this variable is global in the sense that it is across different calls of the function func, but it is only related to only this function func1, let's say func1 or func2 or whatever, basically. So we will say that this is not for other variables, other functions. Now this might be okay, but maybe Cunningham and Ritchie thought that rather than doing this, why not have a facility, this same facility that they require, that some variable which essentially will continue its value across different calls of the same function. And unfortunately, or incidentally, whatever you call it, they chose the same qualifier which is called as static over here. Okay. And they said that if you want to do that, what you do is you do this static int count equal to 0, this kind of declaration. So your assignment, initial assignment and declaration happens together. And then you do count plus plus. Okay. So what happens is the first time you call func1, it gets initialized to 0. And then you do count plus plus, it will print 1. But second time you call func1, now it doesn't look into this because it knows that initialization has already been done. And now it will just increment it to 2, and now the 2 will be printed. Okay, and the third time you do, it will not again initialize, it will keep the earlier value of 2. So 2 plus 1 is 3, and then it will print 3, and likewise. So Cunningham and Ritchie said that we want to provide this facility through our C language. Okay, and they said that if you use this static keyword for the variables which are defined inside the function. So the difference between the earlier static and this static is that this static is inside the function. The earlier static that I talked about, which has nothing to do with this static basically, was to restrict the access of a variable or a function inside a file. Okay, but it was still a global. In this particular case, this static int count is not global. It is to be accessed only inside func1, but the value of this particular variable persists across different calls to the same function, so that it can use the previous value which was set. Okay, and for that so that's why this static comes basically is to be appended or is to be prepended to a declaration which is inside a part of a function. So this count you cannot use in any other function. This is wholesale property of func1 only. Okay, but it will persist its value across different calls. Now, do you think what they will have to do in this case? I mean, how this implementation of this will happen? I mean, will this count be on the activation record? What do you think? Can this count be on the activation record? Can this static int count be on the activation record? No, but for the obvious reason that activation record gets erased basically, right? Every time the function call is over. So this for such static variables which are inside the function, the C programming environment has to create a separate memory, like global variables has. Okay, but it has to make sure that these variables, this static int count, this one is only for func1, and there could be another count coming in which is for func2, etc. And this count should be referred only inside this func1, etc., etc. All those conditions have to be adhered to. So C language inventors said that, okay, this is what our language implementers should do. We want this facility. So of course, this variable is not put on the activation record for obvious reasons, but it is put in a separate section of memory where these globals and statics are written. So globals are still written a little bit separately, who anyone can access. and then the static variables, basically where these static variables which are inside the function. There are two different kinds of static variables. One static is where the file access is restricted, and this static is where the only function access is restricted. So this is the functions static variable. So this static variable is inside the function, and then the compiler will restrict its use only inside that function. Okay, but then because it is written not on the activation record, that value is persisted. I mean, it will be available when the next call to the same function is made. So the small point over here which I'm making is that these variables are not part of the activation records. Okay, so with this we complete our discussion about the qualifiers, where we discussed about the const, then the register and volatile, which are not used anyway longer. But const had said that there are advantages of using const because we are giving a hint to the compiler to do optimizations also, and the value should not change. Many times it is useful. And then we did the extern and the static. But to define that, but to tell you about extern and static, so many other things we need to learn. We need to understand all these things. And finally, the popular use of static, basically, which has nothing to do with the earlier static, is this one. So maybe I always think that Kernighan and Ritchie should have taken a different qualifier over here for the ones which are inside the function. So typically, again, when I used to be in industry and I used to go for recruitments, this was my favorite question, that I would typically like to ask them what is static variables, and of course all the answers would come for this. And very it was very rare, rather it was almost I don't remember anyone answering one or two times except that they would know about anything to do with static global variables, which are over here, which are, if you ask me, are more important from industry perspective. Industry doesn't care about such kind of static variables inside the function, but they will definitely care about programmers knowing how to manage these things, basically the global variables, and restricted to the file and open to all the files and externs and stuff like that, because that is everyday bread and butter for them. Fine. So it is 10:56 in my watch. I don't think I will be able to continue from this point onward. There are a couple of things which are still remaining on this module implementation of the program. And there are some specific, very curious issues which can still arise, and there are curious ways which C language has provided to us. So we'll discuss that in the next lecture. I will start from this one. Very small, one or two topics are remaining now about the C language that we'll finish, and then we'll start with the next topic, which is for arrays. So I'm giving you this as I'm speaking. I'm giving you time to ask you if any doubt is there. There are still 1 or 2 minutes remaining. So if any doubts are there, I can pick them up right now, or if time does not, I will at least answer them in the next lecture. So if there are doubts are there, please put up on the chat box. Otherwise, I think we are done with the class today, and we will meet. The next class is on, if I'm not wrong, is on Monday. So Monday we'll meet at regular time. I think it is at 12 o'clock. So Monday we'll meet at 12 o'clock. So no practicals. So we have decided that practical timing to be on Saturday from 2 to 4. And I think tutorial time on Monday 2 to 3. Is that right, Shiva?
Yes, sir.
Okay. So the no practicals this week. So no practicals tomorrow, because we have not started with what we want to. So again, whether there will be tutorials on Monday or not, it depends on what we take Monday in the first lecture. So on Monday's first half lecture. Okay, so we'll decide. Don't bother. But definitely there will be practicals next week. Okay. So with this, I will stop. I don't see any question coming on the chat box. So looks like everyone has understood it perfectly fine. This is very briefly mentioned in Cunningham Ritchie book. Basically, so now you can just go through the Kernighan and Ritchie book and check. There is a section on qualifiers. You can go now. You will be able to understand that section. Till now, unless all these things are known, that section cannot be understood. That's why many times Kernighan and Ritchie book is understood only after you join industry, because many of the things are just not known. But now you are in a better situation. Perhaps you'll be able to understand. So with this, we will stop today, and we'll meet on Monday at 12 o'clock. Thank you.